it again. And as we said before, it's going to be recorded. So even if you or your friends couldn't join it for some reason, we will send the recording after the webinar anyway, because we have about 55 people or more registered for this webinar. And it was some hustle with the links and everything. Sorry about that, but we just been very crazy busy last weeks, and we needed to push back the webinar last minute for another 2 hours. So we really appreciate your flexibility. But again, it's going to be the recording anyway, so you're not going to miss anything. And so today's webinar, it's basically to give more information about EpiScore, what's going on in EpiScore, what's our plans, and how the technology works for the existing investors, and also for the new people who just discovered us and considering joining the community of investors, of EpiScore investors. And because I have to say it to comply with all of the regulations and SEC requirements, the information that we share right now, it's actually, disclaimer. So the information that we're sharing today, it's really forward-looking statements. It's based on information that our management and our team has today. It's based on our assumptions and our projections and what we see viable in the market. Please do, you should not consider this information as a base for you to make a decision to invest on Start Engine in EpiScore. You have to read all of the documents available on our page on Start Engine, read all of the offering circular, form C on Start Engine. And only based on that information, you have to make a decision to whether invest in us or not. This is more like a just educational information, I would say, to give you some idea where we are. But again, we do not commit to this, and we cannot guarantee that it's going to happen. So the numbers that I'm going to share about the sales and our revenue projections, these are not the information that included in the offering. So you have to read the information there. This is just our assumptions, and it's not the information based on what you have to make a decision to invest in us. So, because I know that there are a lot of people who just discovered us and really don't know what's going on, what's the 3D printed houses, what EpiScore is doing, what's the difference. I'm going to start with the really basic information. And in case you already know that information, I just hope that you're going to enjoy it again. So we are the construction technology company. We develop and manufacture the proprietary 3D printers and equipment to 3D print full-scale houses directly on site. This is the building that we 3D printed in Dubai. And this is actually the Guinness World Record, the largest 3D printed building ever 3D printed on Earth so far. That was a really important project and a huge learning curve for us. After that project, we significantly improved and basically redesigned the equipment. The robot, the 3D printer that you see right now on the screen, it's you can just forget about that. Today, Frank looks completely different. It's much advanced robot today. But even that old version of the equipment was capable to 3D print such a big house. And we were, our goal was to demonstrate that one machine can 3D print a house of 6,400 square feet of living area. And it's 2-story building, but in reality, it looks like 4-story building because each floor is about 4.5 meters, which is about 16 feet, if I'm correct, right, Trevor? 15, yeah, so the total height was 31 feet tall. So again, that was really important for our product development roadmap and how we going to develop the technology further so the construction companies can use it successfully for their construction needs. This is another picture of that building in Dubai. And so now about the equipment that we have. We have a 3D printer and we name it Frank. As you see, Frank is pretty compact and it's pretty comparable to the size of a human. So it's not that huge, big gantry machine that you need to have a lot of trucks and like 10 people just to transport it and deploy the machine. In our case scenario, one personnel can deploy the machine on the construction site and operate the machine to 3D print a house. And this is, you can see that this Frank looks a little bit different than the previous one that I showed in Dubai. Another piece of equipment is a mixer and pump machine, Gary. We also name it Gary. This is also the proprietary equipment that we developed from scratch after our experience in Dubai. We used the pretty standard plastering machine in Dubai, and that was a really nightmare. And we realized that if you want to really scale this technology and 3D print like 1 million of houses, we have to create the special mixer for this technology. Otherwise, it will not be possible to scale it up. So this is Gary. And actually, Gary right now also looks differently. It's new Gary, I would say. And we actually will be we're preparing right now for the product presentation in May or June when we go into unveil new Gary, Frank, and also our 3D printed model house. So a lot of things going on right now, and we're really excited about finally show everything pretty soon this summer. And also the really big difference from other equipment and other 3D printers in the market, is our transportability and mobility of the equipment. So this trailer and this truck is basically enough to transport Frank and Gary to any construction site. And it really takes like 30 minutes to deploy the Gary and Frank on the construction site. So this is basically everything that you need. You don't need to have cranes, you don't need to have pallet jacks or like a big 18-wheeler truck just to transport the printer. This is the really something that we have been working really hard, how to make this technology so easy to use. So it's basically kind of like a transportable tool for the construction. And then another piece of our technology, it's Mary. Mary is a bulk truck that basically transports the 3D print material needed to 3D print the houses. Mary transports dry material because 3D print material comes to the construction site as a dry substance, and then it mixed with water in Gary, and then immediately goes to Frank. So these three pieces together basically represent plug-and-play solution for the construction companies how to utilize this tool to 3D print houses and basically increase productivity, increase the quality of the builds, and also build the durable houses. And I know that a lot of people also wanted to know about what is the 3D print material. So 3D print material, and especially that we use, it's a cement-like mortar, basically concrete, but tweaked a little bit for the extrusion process, for the 3D printing process. And basically it consists of cement, sand, and secret sauce, as we call it. So secret sauce, it's the goal of secret sauce is to make the material extrudable and at the same time durable, and having the fast setting time. So basically have this material suitable for the construction 3D printing process, but also be durable and so we can build safe and sound houses. And also the walls that we 3D print, they are reinforced, because I know that people, everybody see the walls, they like, where's the reinforcement? So we do reinforce the houses, and we do this the same way as it's done for the concrete block construction. And Trevor is the best person to talk about this later on. This is also about the 3D print material. We did test it, and basically the walls that we 3D print, they comply with the building codes as for the concrete masonry unit construction. So now more about the market and the customer profile and why we actually do this technology and for whom. So our customers are construction companies and home builders who really cannot keep up with the demand for the new houses because they rely on labor, which is really limited today. And we do know a lot about the labor shortages. It's also the material shortages. So all of these factors today really make it really hard for construction companies to build a lot of houses to keep up with the demand. It's a lot of time to build a house, it's a lot of costs, and the quality is not really consistent, so that the budget and timeline is also not consistent and not predictable. This is kind of like some items that really affect the overall cost timeline, and this is what actually make the construction so, I would say, challenging and expensive, because all of the things all the time change and you cannot really control it. You cannot really say, okay, this is going to take for me 4 weeks and this is going to take for me this amount of money. No, you can just talk to your subcontractor yesterday and he provide you this price, but tomorrow he call you and say that, you know, my team cannot show up today. When, I don't know when it's going to be continued. So construction companies, they just sit in this situation trying to fix it. So it's a lot of hustle and a lot of problems with that. So with the 3D printing technology, and especially the equipment and technology that we've created, home builders, they can build walls 9 times faster, and I'm talking about the walls. And if you expedite the process of how to build the shell of a house, which is the most important part of a house, if you don't have a shell of a house, you don't have a house, you cannot install roof, windows, work cannot be cannot start it. So if we expedite the wall construction, then the finished houses can be expedited three times. This is a huge game changer for the construction companies. And also for the building the wall structure, we just need 1 person to operate the printer versus about 10 people of a concrete masonry crew on site to build up the same structure. So it really also affects the costs and operational and all of the time and management for this amount of labor, which is also, again, not really available or consistently available. And then the complete houses can be cheaper up to 20%, but it really depends on the design, on location, on your floor plans, and what exact finishes and materials you use. But it is possible to build a very decent, a nice looking, durable, affordable house up to 20% cheaper versus the traditional construction. And again, you just need to have a standard pickup truck and trailer to transport the printer. And our printer is also controlled via iPad, so you don't need to have pallet jacks or 10 people on the construction site just to move the printer around. And printer all the time assembled, so it comes to the construction site as assembled piece, and within 30 minutes, it's ready to start printing. Basically, by our technology, we bring the automation to the construction industry. And what also makes us different, and why home builders so far really like us, and that they actually waiting for our solution being available on the market, because they already did the research, and then they understand the advancement of our technology and all of the features that comes with the mobility, transportability, and ease of use. And now more about the recent updates about the sales and of revenue potential. And again, this is the projections. This is not part of the offering, and it can change anytime, and it's not guaranteed, nothing like that. However, we have been working hard to expedite the sales of our equipment. We started this in late January, in mid-January, and so far we have received a very good demand. So our customers, they just right now preparing their funds to place the order for the machine. They already did a lot of internal calculations and everything. So basically, we have booked revenue, let's say, or like potential revenue for 18 francs. And those people, they didn't just say like, yes, I will buy it. They put $3,000 of the deposit for this machine, and they have to make the decision by within the specific period of time. So this has been pretty solid traction so far. But beside the selling the printers, each sold printer brings the revenue of the material that we're going to sell, because our business model is the kind of the razors and blades. Razors are 3D printers, blades are the 3D print material. So every 3D printer sold or rent out brings the recurring annual revenue of the 3D print material. Approximately, if all of these customers work even like conservatively 8 hours per day, let's say like they build 3-4 houses per month, the potential of revenue for that is $41 million. But again, it can change anytime, and it really depends on all of the risk factors, and it's not guaranteed. Again, it's all of the projections that we receive today based on the pre-orders and all of the commitments from the customers. And also for people who are new here, in addition to that, our fraction also consists of the 2 buildings that we 3D printed in the United States so far, and also the paid pilot that been converted to the commercial contract soon. So we have the proven technology. We already have the pilot projects with the customers who put some money in before, just to, you know, have the reservations or have the priority for our product. And those customers right now, they are being converted to the actual revenue. So this is really exciting. So this is the proof that we don't just have the technology that works. We have the technology that customers want to purchase, want to use, and actually pretty committed to make their orders and put money in very soon. So this year is going to be pretty busy and pretty exciting for us. This is more about market, and I think that it's, you know, pretty obvious that the construction market is huge. But how we calculated it, we see how many new residential houses built in the United States annually. And then we just multiplied by amount the revenue for each house for the 3D print material. This is how we calculated it. Basically, amount of the potential customers and how many of them can pay for us. And so we also have assembled a very good team so far. We work pretty hard, and we're pretty lean and very efficient. So me and Nick, we are 2 co-founders. Before Episcore, we also been in the construction-related business. Especially, we delivered the huge construction-related project on Olympic Games in 2014. It was a $6 million project. It was just 2 of us, and we organized the entire manufacturing and production in the completely different city, and it was successful. We have Trevor Ragnaw. He is the director of construction technologies, been with us for a lot of challenging and hard projects. So he knows a lot about how to build a house and a lot of other stuff. And we also have a lot of great people who help us make business and preparing for the scaling and to expand our manufacturing and production. And we have very good advisor, Paul from Boeing. So he basically helped us to, with this transition from the prototype, how to build prototype, and how to transition to the mass manufacturing of the printers. And now, quick update about the model house. So now I'm just going to switch gears to what is going to happen. So as I said, we are working on to build our model house in Melbourne, Florida, and it's planned to be delivered or like built May or June. And all of the start engine investors, they kind of like in the priority for the first public tours to the model house. And also some perks on the start engine. If you invest the specific amount of money, you can actually attend live printing. You can stay in the 3D printed house for the 1 or 2 nights. So model house is going to be a pretty fun place to be, and a huge milestone for us, because we're going to do a lot of content, and it's also going to be used for our online course for the construction from A to Z. And construction, online construction courses are also perks for the start engine investors if you invest, again, like a specific amount of money. And yeah, this is more about the start engine right now and about the investor perks. Online courses starts from $500 of investment, as I remember. So you basically need to read the description for each perk. And online courses, we distribute every month or every 2 weeks. We try doing this more frequently as we receive the information from Start Engine. And for those who are not familiar with Start Engine, it's qualified and approved by SEC equity crowdfunding platform. They act as a transfer agent and broker dealer for the companies like us and for the investors like you. So all of the investment transaction happens through the Start Engine platform. We don't see your information. All of the personal information that you submit there only goes to the Start Engine, who is the broker dealer, and again, approved by SEC. We only receive your email and names after the entire transaction is completed. And so far, we got almost 700 investors on Start Engine. As of today, we raised $823,000, which is really exciting. So we basically grow in the community of investors and supporters. And it's really important for us because our long-term goal is to really build the community of people who share our vision and will be contributing to our success as well. And before Start Engine, we also were doing Regulation A+. It's kind of the same, but we did it in-house, and we got 250 investors. That's through that offering, and we raised almost $1,200,000. So in general, we almost have 1,000 people invested in us, and we really, really thank to all of them because it really means a lot to us. It means that a lot of people share our vision and really believe that what we are doing is right compared to other companies, for example. So yeah, I invite everyone to invest, and again, read all of the documents there and make your decision on investing in Episcore based on the information available on the Start Engine campaign. This presentation was just to give you the idea who we are and what we're trying to achieve. And on this note, I just going to pass it to Trevor to talk more about the technology, how to build a 3D printed house, and how we also compare it to other robots. Thank you.
Thanks, Anna. Yeah, really great presentation. So my background is in mostly commercial construction, done apartments, multifamily, self-storage, data centers, really a lot that's done more traditionally, and was really excited to get involved with construction 3D printing and see just how similar it is to traditional construction, but how much more efficient it is. I know Anna mentioned the Guinness World Record we have for the largest 3D printed building, but I know there's a lot of questions on permitting. We also have the first commercially permitted 3D printed building in America. So I know we'll talk a little bit more on the permits in a bit, but Essentially, there's a lot more that you can learn about us if you check us out online, things like our patents, multiple awards at NASA, and other buildings that we've printed in the past. I'm going to move here pretty quickly. And again, you can re-watch this after this ends. I believe this recording should be sent to everybody who is in attendance or registered. So yeah, essentially compared to traditional construction, Anna covered some of these here, you're building with a robot, so you reduce a lot of the human error. It's really strong material. It's not like wood that's susceptible to fire, moisture, termites, and everything else. It's extremely durable. And like Anna mentioned, it's up to 9 times faster than block construction. But just as importantly, we know down to the second how long it's going to take to print a building before we ever go out on site. So this allows us to have much better schedules and really much faster delivery than what we'd be able to do otherwise when we're scheduling our trades as well. Money isn't the only green at stake here. It's a huge benefit to the environment when we're using something that has 0 waste. It's all electric and the material's fully recyclable. And my personal favorite here is that we no longer have to build in straight lines and hard corners. We can build a beautiful curved building, or straight lines and hard corners, of course, but we can build just about anything for the same cost as building those straight lines and hard corners. Now, again, this will be recorded, so you can have access to this later. So I'm going to just quickly glance over this. I know somebody asked about the weight of the printer. That's kind of down here. We're looking at about 1.2 tons between the printer and mixer. Just want to address that question really quickly, but this is Frank. Frank is, a truly amazing machine. After seeing a lot of the others in the industry, you can see that spatula come up around the corners. We have really, really good tight corners that we can produce just as easily as straight lines, but we print in multiple sections, and these control joints where the buildings meet, we'll talk about that in a second too. These are required by code and ultimately come down to the quality of the wall that we're putting out. There's a really high quality, really high tolerance, and this helps really speed things up and reduce cost. Yeah, so we kind of get the difference between traditional construction and 3D printed construction, but what about us versus other printers? Anne already mentioned the transportation via truck. This is something that you don't need to be a mathematician to figure out. It's cheaper to transport something with your truck and trailer than it is to pay a commercially licensed truck driver to move 1, 2, maybe 3 trucks worth of equipment used to set up those large gantry printers. The machine arrives fully assembled, and a single person can really go from trailer to first layers in 30 minutes. Whereas the gantry printers, there's a lot of setup involved. It can take sometimes up to 2 weeks, depending on the printer. There's different models and things like that, but there's a lot of assembly required on site. In terms of operation, by having this ecosystem of multiple robots working together, a printer, a mixer, the bulk truck, we're able to really reduce a lot of the human labor that's needed, even compared to these other printers that generally have like a plastering machine that's mixing and they're hand loading material. So smaller crews means reduced cost and reduced chance for human error. And of course, scale. This Frank might be small, but you can print buildings of virtually infinite size. And with these gantry printers, you can only print inside the box. So the bigger the home, the bigger the printer. So talking about printing in multiple sections, this little animation shows Frank rolling off the truck and printing section 1. Now he's going to move over to section 2, and you'll notice that where these two sections combine, that's an abutment or a control joint. Again, required by code. Usually you need a cement saw to cut those things in, and that's dangerous and expensive, but we're doing this all on an automated basis. Another big thing is that since the printer is moving from one section to another, unlike a block crew that kind of does one course at a time, we're able to have a lot of overlapping and concurrent construction activities. So for example, the printer can still be printing a section of the home, but we're putting in lintels and outlets and roughing and plumbing and windows and a lot of insulation, a lot of these secondary activities that typically have to wait in the construction timeline. These overlapping or concurrent activities save time, ultimately save money on your project. And lastly, it allows us to use multiple printers at the same time and even on the same building. Let me show you what that looks like. So up here on the top left, you can kind of see two printers that are actively printing the same structure at the same time. It's something we can already do. But at the same time, you're able to, let's say, as one builder, have multiple printers building different homes kind of next to each other, for example. So this is a great way to show how scalable this is for the businesses that choose to use the APIsCore printer. Scaling up production is as simple as getting new machines. So our big secret to how we're able to get permits and how we're able to integrate secondary construction, do all of these things so easily is because we decided, why reinvent the wall? On the left side of the screen here, you see a concrete block mason and a concrete block machine. On the right side, you see a concrete block machine, and that same machine happens to be the mason here. So the walls are actually identical. And this is kind of weird to wrap your head around, but if you take a concrete block and set it right on top of one of our walls, all the webs match up, all the thicknesses match up, everything is identical. Let's look inside these walls just so you can see what I mean there. So on the left side, we have a standard concrete block wall, the kind of thing you see every day. You'll notice that there's rebar and reinforcement in here. Well, that exact same reinforcement is put into our 3D printed walls, the same spacing with the same grout. There's ladder wire required by code, and we have the same ladder wire. There's a bond beam up top. Of course, we do the exact same thing. So by copying concrete block construction, we aren't needing to create new building codes. It's simply a different robot that makes the same concrete block walls. That's why we've been able to show, IBC compliance and National Concrete Masonry Association compliance, and publish all of these third-party test results through the NFPA, one of the largest creators of the building codes that go into things like the International Building Code. So this is really great from a permitting perspective, but if you're an architect or an engineer, it's also really easy. On the right side here, you see this wall detail. This is a 3D printed wall. If you're familiar with concrete block details, it essentially looks the same, except for these lines are a little squiggly, and it says extruded concrete wall right here. Other than that, they're identical. An architect, an engineer, they essentially already know how to make designs for a 3D printed home because it's virtually the same, with the exception of, let's say, those two little annotations right there. Very quick and easy change. So whether you have an existing set of plans or you want to convert that or design something completely new, it's really easy to work with any architect or engineer to do this kind of thing. But you might be thinking, all right, that it's great for permitting. It's allowed us to really blow through all those barricades. We've really never had any problems obtaining permits, and it helps with the design aspect there. But what about secondary construction? Well, this is, I know, a big question that we have from a lot of people, and ultimately everything can be done in the exact same way as a concrete block home. Thankfully, we have some things that can help make it a little bit more efficient to accomplish the same thing. Example, putting outlets in while the material's still relatively fresh, so it's easier to cut the outlet boxes into the walls, or installing insulation inside the wall cavities instead of putting foam board and drywall on the inside, for example. Our tolerances for windows and doors, it's a robot. We can build those tolerances in very accurately, so there's not as much, shimming and work to do after to trim and pretty everything up. It already comes out of the printer looking great. Down right below on the bottom here, you can kind of see how some of those things look. If you're familiar with concrete block walls, again, it's virtually the same. We've copied the gold standard of construction. Now, if you're interested in learning how to design 3D printed walls, we have plugins for AutoCAD and Revit that make it very quick and easy. We have a video on our YouTube channel and information in APIsCore University that show exactly how to make G-code, but essentially it's a really simple process using the tools architects and engineers are already familiar with, AutoCAD and Revit. And instead of testing that for the first time on the site, we have a simulator that allows you to test it on the computer before ever stepping out onto the construction site. So, we can verify that everything's going to work well when we get out there. Again, I'm sure there's a lot of questions that are still out there. if you haven't had them answered today, feel free to check out some of the resources we have at OptiScore University. It's a really excellent program there. And if you are interested in ever becoming a printer operator, for example, you'll need to take the courses anyway. So feel free to go and check those out. And I will go ahead and pass it back to Anna. I think we might move on to answering some of the questions you've had in the chat. Thanks so much, everyone.
Yeah, thank you, Trevor. That's excellent as always. So actually, when you were doing the presentation, I think that I want to mention something additionally about the building permitting. So as I mentioned, we have 6 pilot projects scheduled for this year, and these pilot projects are done with the early adopters, who are the construction companies. And again, they've been converted from their reservations, from their deposits or something like this we've been doing for like years before. And those are the companies who already did the research and they said, no, we want to work with EpiScore. And I talked to all of them, and the frequently said phrase, it's like it just other printers, it just doesn't make sense. So it's like the most, something that mostly I hear from people and we hear from people. So they understand that mobility, transportability, and also all of the solutions that we created for the construction, like a CMU, like through the printed wall, how to do the installation, how to do the secondary construction, even how to apply for the building permitting. We already learned it in a lot of hard ways. And so the customers see value in us, not only in the equipment that we invented, it's the entire infrastructure and all of the knowledge around that. And the also pretty exciting news is that one of our early adopter, he just recently finally received the building permit for the pilot project. I can't disclose the location and everything right now because we are working on the official announcement, but all of this pilot projects that they are going through the building permitting process right now, and more of them getting very closer and closer to get it, and one of them already received. Also, what I want to say about the online courses. Online courses, it's something that we started developing 2 or 3 years ago, and Trevor is the complete mastermind behind that. So you're gonna listen to Trevor a lot when you get the online course. But the online course, the idea of that was not just to tell about the technology. The idea was to help potential customers to understand how they can incorporate this in their processes and in their construction business. So even our online courses, it's part of the infrastructure to help potential customers using our technology. So I think that now we can jump on some of the questions.
I know I could knock out a few. For example,
Yeah.
are the walls load bearing? Absolutely, they're load bearing. About 33% stronger than concrete blocks. How do you handle or avoid cold joints? Great question. Cold joint, in case you aren't familiar, when you have 2 lifts of concrete, one hardened before the next, there could be a cold joint formed in the 2, or a plane of weakness. Essentially, we've designed the material so we're able to print on previously hardened layers. For example, if we end the shift day 1, we pick it up day 2, we're able to print right on those layers. Typically, we wet them. But when you think about it, and of course, we have a lot of testing that we've published on that 3-point flexural strengths and things of that nature. But when you think about what a concrete block wall is, it's a bunch of hard concrete blocks with fresh, wet mortar put on them to stack and assemble them. You would kind of think that all of those planes would be a cold joint, and I guess they really aren't, but only because they're also reinforced wall cavities. We have reinforcement going from floor to ceiling, so even if you purposefully tried to create a cold joint, you would still have that whole wall bound together by that vertical reinforcement and bond beam up top. So that's how we're able to avoid that. Weight of Frank and Gary, we showed that before. It's about 1.2 tons. I know I see viability of 3D print material in cold winters. If you've seen the yellow tiny home that we printed, very cold out there. Of course, depending on how cold it is, you don't want the material to freeze before it's gained 500 PSI of compressive strength. It's about 24 hours. It can sometimes be covered or heated. That's something that's done with traditional concrete pouring. But if you can't pour a concrete slab in the weather, then you probably shouldn't print in it without using one of those extra measures.
Yeah, and I would add that as of now, the 3D print material that we have can be used only in the above 0 Celsius, so it's not for the cold weathers. However, if you use the additional tools, something like a very fast deployed tent, this is how you can maintain the temperature in the 3D printing area above 0, but it's like extra costs and everything. However, in some of states, it still makes sense, because otherwise construction companies, they don't build at all, because the people cannot work under these conditions. And if you also do the tent and you put 10 or 15 people under this, and also you have to have access for the forklifts and everything, it's not going to work for the traditional construction, but it can work for the for our technology. It's just one machine and one person inside this tent. So this is the solution that some of our potential customers actually considering pretty seriously to implement. But the another way how to use it without tent, it just to tweak the 3D print material so it can be used below 0 Celsius, but we don't have the like a immediate plan to implement it. But like technically, it's possible.
Absolutely. Yeah, I see some other questions in here as well. One, we just passed the cold weather. Is it possible to use technology for constructing not only the main structure, but also the foundation and basement of a building? So great question. Basement walls, yes. We use the technology because it's better, faster, more affordable than the alternative. When it comes to slabs, foundations, it's much better to do this traditionally. Instead of an 1.5-inch pump, you're using a 3-inch or 4-inch concrete pump. It's pumping a lot faster. The material is much less viscous. It flows more easily when you're using a ready mix truck than our material. It's kind of like painting a wall with a Sharpie marker. You know, the Sharpie is really accurate. That's what the printer does. But when you're just filling up form work, I'd still recommend using traditional concrete for something like that.
Yeah, and also about the foundations. So foundation is typically like a big solid slab, and it's still much faster and much more affordable just to build it traditionally when you just pour the concrete on that. I use this analogy. It's like the same as you use the small pen, like a pencil, to paint the wall. Right? It's just not going to work. You use the big brush to quickly paint the wall. So this is basically the foundation, because the printer is basically the pencil. And printer, we use 3D printing technology to create the volumetric objects like walls. The foundation is still like a big solid stuff. Let's build it traditionally. It's already very good. Nothing to innovate there, I would say. Yeah.
Yeah, I actually see another good question here. It said, what's the logic of having a huge truck for printing material versus driving it in smaller containers for several pickup truck deliveries to unload on site? The first thing is that this material, concrete, whether it's concrete blocks or the print material, it's really heavy. It's not something you're going to be able to get to site with general pickup trucks. When you see a concrete block home being made, you see an 18-wheeler pull up, and then you see pallets of concrete blocks getting unloaded off of the truck. So whether you're doing per pallet. So you're going to have generally multiple truck stops, and with that truck stop, you need something to unload it with. Once it's out on site, the print material, we know we've done this in the past with the super sacks. You can try to store pallets. They ultimately end up taking up more room on site, and they're exposed to moisture. You know, this print material loves water. It'll take humidity out of the air. And it's like frying an egg. Once that reaction happens with water and cement, you can't unfry the egg. You can't undo that reaction. So this will really compromise the quality of the print material. So by using the bulk truck, we eliminate the need to have the same amount of area really needed on site for storage. We keep that material in a vacuum sealed environment from the time it leaves the batch plant to the time it exits the extruder through the entire system. Big closed loop, whether it's raining, snowing, whatever it might be. That material is essentially coming out of a factory. And the really the bulk truck in its total size, it's about what you'd see for a garbage truck that's coming in and picking up garbage outside of a residential neighborhood. So we already have these kind of trucks, or at least garbage trucks, things the same size, passing by our homes pretty frequently. It tends to be a pretty small form factor. With that being said, in the past, like in Dubai, the bulk truck would arrive and fill up a silo on site, and we'd feed off that silo. We really recommend using the bulk truck, so you don't have to transport a silo and a bulk truck to the site. But when you look at how other people are loading on print material and seeing people hanging bulk sacks above with a forklift above a big hopper, and manually trying to feed things, and seeing what that result is in terms of quality on the other end. We've done it both ways. We know this is the best way just from experience and seeing what the rest of the industry is doing. So this ultimately is.
And the entire idea of this process, it's how to get less people on the construction site, less equipment, and basically do the process as a plug and play. If you just deliver this in the smaller containers, it's actually not how it's going to work, because the material that we produce, it's a dry mortar material. Nobody batch it in containers. They only batch it in a big white 3,000-pound bags. And as Trevor said, you need to do a lot of over-engineering stuff with a lot of people to actually make it happen. And it's also not our words. The potential customers who already in the process to use our technology, they used the another printers before, and those companies, they didn't have Mary. They even today they don't have Mary, and those customers said that like we don't want to have to experience that process again, because managing all of this like 50 bags, 3,000 pounds each on the construction site, it's like it's a very luxury. It's not something that we need to have. A lot of space, a lot of logistic costs, a lot of people. It's just not scalable approach. So this is why we developed this material delivery system, which is Mary, to make this process really scalable and reduce all of the costs to deliver this amount of material, because it's actually a lot of material needed to 3D print the house. It's not just 2-3 bags or like 2-3 trailers. So all of this logic is behind that.
Yeah, and following off that question, seeing questions about who supplies the truck with the dry printing material, that's something that we supply. You don't have to have your own bulk truck. Thankfully, there are thousands of bulk trucks driving all across the nation right now transporting dry materials like this. And it's very easy for us to convert them. We basically put a small black box on it, allows its pneumatic pump to communicate with Gary. So that's a very easy piece of technology to integrate. And of course, they come in different sizes, these bulk trucks, but Mary is a pretty standard bulk truck size.
Yep, exactly.
And I guess the last one there was, can you print or precast any, can you print precast or pre-stressed elements? So nothing, yeah, I guess kind of. Sometimes we'll print lintels on the ground or some elements on the ground. So that way, once we print up to the window height or head height, that element is hardened and we can pick it up and put it into place. There are definitely a lot of things that you can do with a 3D printer besides just printing the wall sections, printing under cabinets, printing, we've even seen people, print furniture and things like that. We're mainly focused on the walls, but hey, if you're using our material and our printer and you're staying productive with it, then have fun. But there are a lot of things that these pre-stressed and precast elements, these are things that, it is concrete. You can do these things and things can be incorporated in there, whether it's a non-printed element that you're incorporating into your building or whether it's a printed element that you're adding reinforcement to later. These are things that can happen. I
Yeah,
think
and
that's covered.
I think, Trevor, in addition to that, it's we also 3D print the lintels, right? For the doors and window scheduling. So we 3D print basically the formwork for that, and then we filled it with the regular concrete. So it's kind of like a halfway printed, halfway precasted, kind of like a combination of that. But yeah, if it's a part of the wall and it's supposed to be 3D printed, we can do that and combine it with the traditional construction as well. Maybe Trevor, you can take the last one about the paint for the house.
Yeah, late spec. Yeah, so you can use any paint that's approved for masonry. By painting early on, if you're able to retain some of the mixed water, you can gain compressive strength a little bit more quickly. And the thing you don't want to do is have too much, like some of the oil-based paints, if they go on too early when the material is still curing and vapors being driven out of the print material, then it could bubble, but it's the exact same as any other concrete. So if it's poured concrete, what you'd be able to put on a slab or foundation, we follow all the same essentially rules there. So, same paint, same coatings. All those things can work well with a 3D printed home.
Yep. And also I see the question about did you develop the simulation program for time and material costs? So if I understand this question correctly, so we did develop the proprietary software to control the printer, and Gary, basically the controlling software, we developed this. It's also part of our proprietary technology. For the simulation, we also have a proprietary piece of software for that. So basically, when you 3D print the house, you can see all of the movements of the printer and where the extruder is, and even from which side the spatula is. So that's actually very helpful, because before we needed to go and all the time visually checked it, just to make sure that we don't cut the layers in between. But now we can just see it from our software. This is also something that we're really excited to present this summer as part of our product presentation. In addition to that, we have developed the plug-in for AutoCAD. It's something that Trevor talked before about. It's more about how to create G-code, how to translate the construction documents and blueprints to the Frank language. So we also developed that. For the material costs, we don't have the software for that. Basically, we just need to know the total square footage of the wall area. And then we use SketchUp, for example, to calculate this area. We have the tutorial video for that. Since we know how much material we use for the 1 square foot of the wall, of the piece of the wall, then we just apply it and we know how much total we need the material. So it's kind of like a manual process, but it's not that hard process. For all of the secondary construction, that's a standard cost estimate process when you have the estimated company, for example, or you have the software for that, and the software can provide you the numbers for the roofing, for the windows, for all of the other parts of the house to finish the house beside the walls, based on the national statistics or something like that. So it's pretty sophisticated software that can pull numbers pretty quickly. So we don't have to create the software for that. Another question, do you print the forms for the foundation? Also, do you print the basements? Yeah, Trevor already addressed that about the basements. We actually can print the formwork if it's like a lintel foundation, not the concrete slab. So you can print the lintel foundation because it's basically kind of like a walls. and then you filled it with the regular concrete, yes, you can do that. So it looks like we answered all of the questions. Yep.
Yeah, I think we're running a little over here on the time. So just want to respect everybody's time who did decide to show up here today. Yeah, thanks so much for coming here. And we look forward to seeing you on the next webinar, and you'll be getting a copy of this here fairly soon.
Yeah, we will send the follow-up email with the link to the Start Engine, link to join the invitation list for the public tours to the 3D printed house, link to this recording. So yeah, make sure you check your email for spam or whatever folders are to make sure you receive that. If you don't receive it, you can reach out to Kamari. She sent out the invitation email for this webinar before. So yeah, you know how to reach us if you need anything. Thank you so much for your time, and we really enjoyed this webinar. Thank you, Trevor.
Thanks, everybody. Thanks, Anna.
Thanks. Bye.